you can begin.
Good afternoon, everybody, and a warm welcome to my presentation. My name is Nast, and today I will present a collaborative research work between Bauhaus-Universität Weimar, Germany, and Polytechnic of Milan, Italy. In our study, we explore ontology-based cost management in public infrastructure products. And today, we will have a closer look on a case study on transferability and applicability. There is no doubt we have a rarely grown research interest in ontology-based approaches for construction tasks. And maybe this paper, this contribution, is follow-up conversation about the things we have discussed yesterday in Committee for Standards and Modeling. In a review published 2023, they identified 142 journal papers on ontology applications. And the EC3 community lookup service listed 145 built environment ontologies. However, ontologies for cost management have two main research limitations. First, they provide a static cost perspective. They have limited consideration of how cost information evolves across product phases. Second, they have limited validation scope. The validation often remains restricted to a single domain or national context, limiting transferability and scalability. In our research, we have focused on the second limitation, limited validation scope. The research aim is to investigate whether an ontology-based cost management approach can be transferred and applied to infrastructure products within a different national cost management context. Let's have a quick look at our analytical focus. Analytical focus are these four dimensions: transferability, applicability, scalability, and generalizability. Transferability means the reuse across construction domains. Applicability refers to the implementing in another national context. Scalability means supporting for different product sizes and work types. And generalizability means validation beyond a single case study approach. Our reference approach was ontology-based cost management model, published in Research 2023 by Jacopo Cassandro, Polytechnic of Milan, Italy. This ontology-based approach has a huge potential. Its conceptual structure is designed to support multiple domains and national standards. But current validation was mainly building products within the Italian regulatory framework. And what we are going to do, the target validation to transfer it to infrastructure products within the German regulatory framework. A reference product was developed as a case study representing the typical characteristic of a small-scale railway project. Why railways? Around 80 till 90% of railway stations are simple stations with side platforms in Germany, and I think also in other European countries, but I have not the exact numbers. Passenger stations products were selected because they have a high degree of standardization and they have received limited attention in previous research on cost management, ontologies, and also 5D BIM. A reference product includes product description, construction scheduler, BIM model, bill of quantities, and is based on construction standards for passenger railway stations and digital library of construction components. If I talk about digital library, I talk about more than 600 BIM elements and components standardized and used by different stakeholders in the project. The reference product was used, and we have selected some cost items for this paper because normally you have bill of quantities with more than 100 positions, more 100 cost items. We selected a couple of them. The selected cost items of the reference product can be decomposed into semantically well-defined components like construction work, material resource, activity, technical and performance specification. This study demonstrates how existing ontologies can be reused and integrated to structure cost items and establish semantic links to geometric data. The ontologies we have used are IFCO ontology, cost item ontology, construction resource ontology, and also quid ontology for measurement. As a result, quantities, cost item definitions, and unit prices are no longer managed as separate artifacts, but are integrated into a single machine interpretable model. Through the integration of these ontologies, a unified knowledge graph is generated in which each cost item is explicitly linked to one or more corresponding geometric objects. So, evaluation. Reuse of the ontology-based cost management approach depends on whether cost items can be described in a structured and semantically consistent way. Although pricing mechanisms differ between building construction and infrastructure products, the study shows a fundamental commonality in cost calculation. The semantic structure and granularity of cost information are consistent across domains, irrespective of national or organizational specific cost management practices. Cost values can be modified, compared, and reassigned without affecting the semantic integrity of cost items, directly supporting the methodological assumption of separating meaning from money value. What's about transferability? We have applied a cost model in both building construction and infrastructure products, and we have seen there is no fundamental change to core ontological classes and relationships. Applicability we have shown by adapting to a different national and organizational context, the domain instead of the Italian context. Scalability was supported through the selection of small-scale products, very rarely in the literature, but very relevant for the industry adoption, as well by including different construction activities. Generalizability was achieved through the use of a reference product derived from approximately 9,300 railway station platforms. So all the railway stations, small-scale projects we have in Germany, was conducted in this reference product. What's about further research? Further research should address the first limitation of ontology-based approaches for cost management, namely extend the ontology-based approach to early cost estimation and demonstrate the dynamic evolution of cost information across product phases. So, you know, the first limitation I have shown you in the beginning of my presentation. Additionally, the method demonstrated in this case study can be formalized for proven transferability and applicability across domains and national contexts. Thank you very much for your attention, and I'm open for your questions.